Howard, welcome to the podcast, man.
Hey, thanks. Thanks for having me here.
No worries, man. It's been good. I've been waiting a while to have you on. I've got a bit of a funny question for you first up. Bit of a question out of left field. What's the possibility of a block hash being Howard Cho is the sexiest man alive for 2069 YOLO?
That's a 256-bit hash. You're talking, astronomically unlikely.
So it probably segues good into the next question about RandomX. Obviously, for those who don't know, you're the man who originally designed RandomX. So that's quite a big feat itself. It begs a few questions from me. So RandomX, break it down to me like I'm five, right? So what's the purpose of it? What's the actual benefits of it versus something like SHA-256?
Okay. So, you understand the reason that we do proof of work in the first place, right? I don't need to cover that. But, so SHA-256 is a cryptographic hashing algorithm. It was designed to be very fast and easy to compute. Okay, and the fact that it's very easy to compute means it is so simple that you can optimize it on dedicated hardware very easily. Okay, and so, as we see, Bitcoin mining is all dominated by ASICs, special purpose chips, built specifically to compute SHA-256 as fast as possible. And what this does is it means the only people who can play in the Bitcoin mining space are, these well-established chip designers. And that means not just anybody can get their hands on mining hardware. They have to go through these very limited suppliers, and and those suppliers are now doing KYC. Okay, so, originally, if you were mining Bitcoin, when it launched in 2008, 2009, if you were mining on your PC, then you were completely anonymous. Nobody knew who you were, and you were generating these coins with no regulatory supervision. But now, Bitcoin mining is so tightly controlled because the sources, the suppliers are limited. They basically have a chokehold over the ecosystem, because it's unlikely that any new player can enter the space and design ASIC hardware that will outcompete what the established guys are doing. So that's the situation that we want to avoid with RandomX. The purpose is to return mining to its original roots, which was one CPU equals one vote, where anybody with a personal computer can participate, and nobody can regulate their activity. And so the concept that makes it all work is to say, why don't these other mining algorithms work to defeat ASICs? And the reason is because they are single algorithms. And for any single algorithm, you can build a dedicated chip. All right? And if the algorithm is small enough, you can put thousands of instances of these chips, thousands of instances of these mining circuits on a single chip. And that's what makes ASICs so powerful, right? You've got a single chip that can have, say, 4,096 instances of a SHA-256 circuit, and they're all running in parallel. They're all running at full speed. And so what we wanted to do was say, what's the difference between a CPU and an ASIC? What is the defining fundamental difference between them? And the difference is that an ASIC is built to do only one thing, and a CPU is built to do anything. Right? It's not built to do one specific thing. It's built to run programs that you can write to make it do anything you want. And so to create a mining algorithm that is dedicated to CPUs, that only CPUs have an advantage running, you have to leverage all the things that make a CPU what it is. So you have to make a mining algorithm that isn't a single algorithm. It has to be arbitrary programs. That's the basic concept.
So the economic incentive of ASICs as well is to centralize too. So what's to stop somebody like dominating the hash power by buying a lot of CPUs and then just having them in one sort of area?
Uh, well, I mean, obviously money is part of the limit, but there's too much global demand for CPUs. So in some ways, it's a self-limiting ecosystem as well, right? You can't just buy 5 million CPUs. I mean, there's too much other market demand for them. You could say, okay, I'm going to rent, 90% of the hash power at Amazon or AWS. Even that would be difficult to do because there are other customers for Amazon, and they're not going to want to piss off their large customers just to serve one. So that's one of the limits. One of the things we saw in the early days in 2019, 2020, we saw large spikes of hash power show up. And we're like, whoa, what's going on there? And it turned out to be somebody, taking a bunch of free accounts on Microsoft Azure and just signing up hundreds of them as fast as he could. And so he'd spin up hash power, and then Microsoft would notice their CPU use go through the roof, and they'd shut them all down. So there's a lot of these things that have limiting mechanisms on them, right? But the main thing is, I mean, anybody can buy like one CPU. They can go to their local store or whatever, local electronic shop, computer shop. That's not hard. But to buy massive numbers is not really practical.
So people can still run ASICs on Monero, but although it's inefficient, they can still do it, right?
You can build an ASIC for RandomX, yeah, but to do that, you would need all the functional units of a CPU. You would essentially be building a CPU. And so there would be no cost benefit.
So you mentioned before about the different parts of the computer that's needed to run the random algorithm. Break that down to me like I'm 5. What parts are needed?
Okay, well, for example, a CPU has 2 different types of math units, right? It has one for integer arithmetic and one for floating point arithmetic. Okay, so you need both of those parts at the very, very least. The other thing that's really important is a CPU has a mechanism for reading a program and executing it one step at a time. So these are, instruction fetchers and program counters. Right, the instruction fetcher that says, go get me the next instruction, and the program counter that tells, where am I in this program? Right, there's these pieces that are not normally part of an ASIC. Right, an ASIC doesn't have a program to run. It just has, a static circuit that says you feed input in one side, and a bunch of switches flip, and then you get an output out the other side. But a programmable computer has to be able to read program instructions and do something useful with them. The other thing too is, most programs don't just run start to finish in a line, right? They have branches, they have loops, right? So, a CPU needs to have special hardware for handling branches. They call them branch predictors, and loop counters and these sorts of things. And again, these are things that ASICs don't need to have. So there's a whole bunch of features that we use in RandomX that a typical ASIC would not have.
So I think the idea for RandomX is something that most people wouldn't think about. Like when I first learnt about it, it was pretty unique concept. I thought about it, I was like, that's pretty good, But what actually gave it inspiration to create RandomX?
In 2018, everyone was talking about how it would be unsustainable for Monero to keep changing its hash algorithm every hard fork. And it was obvious. It was obvious that is unsustainable. And so I was just looking around, thinking, okay, how can we make a long-term algorithm that we don't need to change every 6 months? And the idea was simple. It's like, okay, the way to do this is to make something that isn't a single algorithm. And the way to do that is to generate random programs. Now, the idea that I actually came up with first was to generate random JavaScript programs. And we actually spent several months trying to prototype that and make it secure and stable, and we found that we couldn't actually make it secure. So our first effort was a dead end. And the two major obstacles we had with the random JavaScript code turned out to have a simple solution that Tevidor actually proposed. He said, well, because when you're trying to generate a random program, you have to follow the rules of the programming language, right? So a lot of random values that you generate won't be valid in the programming language. They'll have invalid syntax, and so you're throwing away a lot of random stuff that you generate. You're doing a lot of wasted work. What if we had a language that has no syntax, where every numeric value that you use is a valid instruction, which means we're talking about machine language now. We're talking about instead of high-level languages like JavaScript or C, we're talking about just bytes of code, and so that's really the path that we took.
So I want to talk about protecting Monero from attacks. So what are some possible attack vectors?
You have to define what you mean by attack, right? There's attacking the cryptography, and there's attacking the operation of the network, right? And people have already tried both. There was one attack that we still see occasionally of somebody putting up a whole bunch of malicious nodes that spit out bogus information when other nodes try to contact them. So that's an attack mechanism that can actually work if you control enough nodes, right? If you have 50% of the nodes on the network and they're all spewing malicious data, then you can give things a hard time. Also, with say a large percentage of nodes on the network, you can start trying to record the IP addresses of everybody submitting transactions, right? So those are some of the attacks that are possible. And obviously the latter one, you can defeat that using Tor or I2P, and Dandelion, which Monero implements, can give some protection against that as well. So there's attacks where you're trying to interfere with the smooth operation of the network. You can talk about attacks on mining operation. Again, 51% attacks. Everyone's discussed that. And you can talk about attacks on de-anonymizing the transactions historically, right? And that's something. I suppose that's the most fruitful point of attack, because the blockchain is forever. So 10 years from now, you could be developing a technique to de-anonymize the transactions from today, right? I suppose those are the different factors that we talk about.
One thing I want to talk about is probably the best thing I've seen all year, or whether it was last year or whenever it was. You seem to be mining Monero from your car GPS. That's possibly, like I say, the best thing I've ever seen. How you got the idea, I'll never know. So just expand a little bit more on that.
I was actually talking about that for a couple of weeks in the Monero POW channel before I got that. It's the car radio that I just bought recently. It runs Android. I was like, oh, this thing runs Android. I can put my own software on it. And also, maybe I should back up a step. So, the stock car radio in my car, which I've owned for many years now, has always annoyed me because the clock runs slow. It loses like a minute every week, right? So finally, it's like, I'm going to get an aftermarket radio to replace this thing, one with an actual decent working clock, all right? And I go shopping around online and I see, the car radios that you can buy now aftermarket all run Android. This is pretty cool. So then I was like, oh, too bad, it only has 1 GB of RAM or something. And I went shopping further, searching some more. I found, wow, this thing's got 8 GB. It's got an 8-core CPU. This is fantastic, right? So I ordered that, had it installed, and I immediately said, I've got this thing that's more powerful than my smartphone sitting in my car radio now. I should try and see if I can get the miner running on it. And I downloaded Termux onto the car radio, and Termux is an Android application that gives you a Linux runtime environment. And so from there, I basically installed Git and downloaded the Monero source code or the RandomX source code and the XMRig source and just started building and running to see what would work. And lo and behold, it all works. So I was pretty pleased with that. On that one, I think it was 300 or 400 hashes a second, but again, that wasn't using every CPU core available. I wanted to still be able to listen to the radio.
Is there any way for idiots like me to do it without being like a tech wizard like yourself?
Well, if you have that Android car radio, it's actually not that hard. There's several tutorials on how to set up XMRig on an Android system, like your smartphone or whatever. So the steps aren't all that different. One of the things that's clumsy is there's no keyboard, and so you're just using the standard Android on-screen keyboard, and I find that unpleasant to type on. But once you've gotten things set up, you don't really have to do a lot of typing.
It's crazy, man. I actually love it. Why didn't you decide to work on Bitcoin? Why did you decide to move over to Monero?
When Bitcoin was announced back in 2008 or so, I took one look at it and said, this is the stupidest data structure design I've ever seen. It'll never scale. A blockchain that's meant to handle worldwide, global transaction traffic on a linear data structure, that's just inherently non-scalable. And so I dismissed it. I said, this is bullshit, and it's not going anywhere. And also at the same time, Android had just been released, and I had started hacking on the Google phone, the G1. And so I was just, occupied with other more interesting stuff to do. I didn't actually get involved in anything crypto related, again, because, inherently I believe that, the technology is unfit for purpose. And then it wasn't until 2014, 2015 that, Fluffy Pony Ricardo contacted me on IRC and said, hey, we want to, I'm running this new crypto project, and we want to look at using your database LMDB with it. And I said, cool, have fun with that. Again, I had no interest whatsoever. And it wasn't until 2016 when the Monero guys had already gotten most of their integration completed, and they were having a couple issues with 32-bit Windows support. And they asked me to have a look at it. I said, okay, sure, I'll help you out. And so that's when I actually got involved. And as I got involved, I started reading all the CryptoNote white papers and the other docs I could find on the subject. And I thought, there's actually something to this. The fact that it's private by default makes it more viable than all the other crypto projects I've heard of, between 2008 and 2015. So,
what do you say to the maxis who say that Bitcoin is basically on a scaling layers like the internet?
Yeah, that's a bunch of nonsense. For example, they talk about Lightning being layer 2, and by any definition of protocol layering, it's not a layer. It's a completely separate network. It's a completely separate network with completely different security characteristics. And it's mostly centralized. So, Yeah, that's all nonsense. If you want to talk about layering, you need something that's actually built on top of something else, right? And Lightning isn't built on top of the Bitcoin layer 1 network. It's a completely separate network. I mean, that there's just no logic to that. And if you look at network layering, for example, at least the first 20 years of my career was in internet protocol design, right? Layering is where every successive protocol builds directly on top of the one below it. Just like in TCP/IP, you've got the IP layer, which is raw packets, and then you've got TCP on top of that, and and the IP layer itself is carried on top of some other layers, say Ethernet or fiber optic or whatever. And the characteristic you see in all of this is the lowest layers are always faster than the highest layers. The Ethernet signaling layer runs at 10 megabits per second, but at the IP layer, you're not getting 10 megabits of throughput there. You're only getting like 8 megabits of throughput because there's headers and signaling overhead and all this other stuff. And then at the TCP layer, you're not getting 8 megabits. You're getting 7 or 6 or 5, again because there's IP headers. And so every time you add layers on something, you add overhead that reduces the overall throughput. And so to say that you can add a new layer onto a slow system that makes the slow system fast, that's bullshit. There's nothing in reality that works that way. If you want to build a fast system, it has to be fast at the bottommost layers, because every time you add a layer, you lose speed. You don't gain it.
So, sticking on the subject of scalability, obviously in the background here, I've got a newspaper, Bitcoin Day in El Salvador. I'm in El Salvador at the moment. Bitcoin's legal tender here. Not many people are adopting it, but that's not the point I want to talk about. I really want to talk about having something adopted as a digital cash. Now, when you look at like the solutions we have in society today, so whether that's cash, FPOS, bank cards in general, right? It's pretty instant, and I think anything that's going to be adopted really needs to be obviously as good as, if not better. Now, with the 2-minute block times in Monero, that can make things difficult. Obviously, if you've got to wait for confirmation. Some people obviously advocate for having 0 confirmation transactions. And it might be a broader question as well as where you actually see Monero headed in society. But how do you think, well, firstly, where do you see Monero headed in society? What role do you think it's going to play? And what solutions do you think are there or need to be there to be implemented to, broader society, to normies, if you will?
Yeah, those are some bigger questions. First, if we talk about, transaction speed and block times, you're not really comparing apples to apples, right? When somebody pays with a credit card and it looks instant, settlement doesn't really happen until 30 days later, right? So merchants are going out on a limb. They're taking a risk that the transaction won't actually be honored when they try and settle it 30 days later. And to a large extent, the credit card system tries to mitigate this, right? They have insurance and some other, chargeback policies and that sort of thing. So, so transaction speeds aren't really a fair comparison there, right? The credit card looks instant, but it's really on a 30-day cycle or something. And maybe this is something that the cryptocurrency industry as a whole needs to look at and take to heart and say, okay, if we can't actually have instantaneous global settlement, maybe we should think about how to do delayed settlement with mitigations. I think that's really the more practical approach. Zero conf is fine if you're buying a pack of gum or a cup of coffee or something, but for other things, it may not be, it may be too much for the merchant to trust. On the flip side, I think 2 minutes is actually not a big deal, right? If I walk into a shop, or if I walk into a coffee shop and I buy a coffee and a muffin, I'm not actually going to stand at the checkout counter for 2 minutes, right? I'm going to place my order and walk down to the other side of the counter where I pick up the order, and it's going to be more, 5 minutes between when I place the order and when I pick up the order. So a 2-minute confirmation time isn't really a big deal. It's and in a lot of face-to-face shopping experiences, it doesn't really make any difference. As far
Yeah, I hear you, man.
yeah.
I think in some situations, say like the grocery store, like you can't necessarily wait 2 minutes to, you know, I mean, I did it actually. Supposedly, I accidentally made a main chain transaction in the supermarket just down the road here. And luckily, it didn't take 10 minutes. It only took 3 or 4 minutes, right?
Yeah.
But the people behind me were livid, you know what I mean? And even for me, I'm sitting there, all embarrassed, like, fuck, this is, thinking it's lightning, this is supposed to be instant, blah, blah, blah. So I don't think that would scale, but do you think that if you're talking about having, like, I suppose, mediators, a different system that I suppose scales to people, do you not think that, like, negates the purpose of having, I suppose, a separate network, a separate monetary network in the first place?
Yeah, that's a fair question. I don't know the answer to how to reconcile those two yet. Not at this point. And the large question of where do we see cryptocurrencies fitting into the real world or normies adoption? I think it's still too early for that even to be a real thing. Now, as we see governments talking about CBDCs, central bank digital currencies, and as those rollouts come closer to reality, I think then it becomes more of a pressing question of how we get cryptocurrencies into everybody's hands. So right now the demand really isn't there and the urgency isn't really there. Unless you live in like a country under sanctions or in a country that oppresses your religion or those sorts of things. Unless you're living under very oppressive circumstances, cryptocurrency isn't offering much to you right now. But if you are in one of those oppressed situations, then cryptocurrency today is very useful. So there's so in a sense, what we're saying is the world has to get a lot shittier before cryptocurrency becomes important to normal people.
I actually think your thesis is pretty much exactly the same as mine. I think, like anything, like any new invention, people need an incentive to adopt anything, right? If there's no reason to adopt something, they're not going to adopt it. I suppose it begs a bigger question as well. You just touched on it. CBDCs and social credit scores. We kind of know where they are at the moment. How do you think they're going to play out?
I watch those Black Mirror episodes, and I mean, it's hard to predict anything, but that is obviously one way that things could go. And if you look at, the pilots in China, I mean, that kind of is tending that way. Now, all of that comes about because those are, authoritarian societies that are being depicted, and that points out to us that there's a very real danger that we all live in now of going down that authoritarian path, and we need to fight against that as much as possible. Social credit scores are, I mean, that's the very definition of authoritarian, right? The government telling you what you can and can't do. For most of the world, we're not there yet, but I think we're on a path that could take us there, certainly.
Howard, thanks so much for coming on, man.
All right. My pleasure. Thanks for having me on.